Welcome back. So let's move on to part 3, step 3 of solving a problem, or at least trying to. So we understand the problem, we explored concrete examples. Now, before we start typing code, I like to break it down. And I actually like to do, it sounds like, I don't start dancing in the middle of the interview. By break it down, I mean take the actual steps of the problem and write them down. It doesn't have to be full pseudocode. It doesn't have to be valid, syntax. I like to do just little comments as a guide for the steps I need to take. And especially in an interview setting, this is really important. What a lot of interviewers are looking for is, you to communicate what you're doing. You don't want to just start typing right away or start writing code on a whiteboard silently with your brow furrowed, angrily writing code. It's much better to say, all right, here's the steps I'm going to try and take. Sometimes you can get a little hint too. You can throw in, do you think that'll work? Or, does that sound crazy to you? Or could this be the right way of doing it? And sometimes they'll give you a little hint. So breaking it down can be really important. So I recommend explicitly writing out the steps that you need to take. It doesn't have to be a ton of detail. It doesn't have to be line by line, every line you need to write. Just the basic components of the solution. So this forces you to think about your code before you actually write it, so that you're not just freewheeling and trying to come up with it on the fly. And it also helps you kind of catch or figure out any lingering questions or parts that you're scared of or that you don't understand. So that's why I really recommend doing this. It helps you just lay out your steps, and that's always nice, and it helps you stay focused. But also it helps you highlight the problems you might still not be confident about. And then you can just dive in and start writing the code. So let me show you what it looks like if I were to break down this same problem. Write a function which takes in a string and returns counts of each character in the string. So the same problem from before. All right, so I have a sheet of paper or a whiteboard or whatever it is in my interview. I've written down some examples, and now I'm going to type up the skeleton of my function. So we'll call it char count, and we know that it accepts a string. It's called str. And then I'm going to stop with the actual code, and I'm going to start writing some comments. I'm going to break it down for myself. And the simplest thing we could start with is just do something, and then add in our return value. Return an object with keys that are lowercase alphanumeric characters in the string. So just to clarify, I've decided, or my interviewer decided, that we only need to care about alphanumeric characters, lowercase as well. So that means, in this example, your PIN number is 1234. We are keeping track of the numbers, and we are keeping track of all letters, but only lowercasing them. So PIN, PIN, we're going to keep that, a 1 lowercase p, 2 lowercase i's, this one here, and this one here. Okay, so we could start with something simple like this, put our return value down there. I'm going to duplicate this and expand upon it. So if we think about the actual steps of what we want to do, well, we're going to need to do something once for every character in the string, right? We're going to need to go over it. At some point, we also need to make an object that we're going to return at the very end, right? That one's simple. We need to make the thing that we're going to return. We need to return it at the end. But the bulk of the logic involves looping over every character in our string and doing something. So I might start, let's get rid of this and simplify this a bit. I would start with something like make object to return at end. Then after that, I would do, loop over string, and we'll come back and fill in the detail. And then return object at end. So now we have the very basic steps, and we can, fill in the blanks, but looping over string is definitely the bulk of our logic. So what do we need to do? Well, if we loop over the string, we know that we're going to need to look at each character, and let's start with y. We're going to need to look at y and lowercase it. So we could lowercase the entire string at the beginning. That's one option. Or we could lowercase each character as we go. But we're going to start by taking a look at this character. And what do? We check, well, are there any in our object already? And technically it's going to start out empty, so there's nothing in there. So then we would add y in and set its count to 1. But if there already was a y in that object, then we would add 1 to it. So that's really the logic. We're going to loop over string for each character. Then we'll do something like if I'll just do char, is in our object, let's say is a key in object, add 1 to count. if the character is not in our object, add it and set value to 1. So that makes sense. Although this isn't accounting for the fact that we only care about alphanumeric characters. So the spaces we're not going to add in. The exclamation point we won't add in. So we should clarify that. We should say if the character is a number / letter and is a key in our object, add 1 to count. If the character is a number / letter and not in our object, add it to the object and set value to 1. And then otherwise, we'll say like if character is something else, a space, a period, etc., don't do anything. And then at the very end, we return our object. So we make our object at the beginning, then we go character by character. We have our main logic. It will just be a loop, probably a for loop. And then we'll take each character, look at it, make sure, check, is it alphanumeric? Is it a number or a letter? If it is, then we will add it into our object. And that means either incrementing an existing part of our object or adding it to the object and setting its value to 1. And if it's not alphanumeric, we just don't do anything. So we build up our object 1 character at a time, and then we return it at the very end. And now that we have these basic steps, we can now go fill in the blanks. And I highly recommend, this is a simpler problem. Some of you probably could have, a lot of you probably could solve this without having to do any of this, pseudocode. And this isn't even full pseudocode, but just writing these comments out. But for more complicated problems, it really can be a lifesaver, because if you write out the steps, especially in an interview, you write out the steps, you know what you need to do, even if you're not sure how to accomplish it. It demonstrates to your interviewer that you at least have formulated an approach. And if you run out of time and you only get halfway there, but you have the layout for what you would have done. So like if we stopped here, for example, this is a short problem, but let's say this is where we ran out of time. Everything is implemented in code. If we have these notes down here, our interviewer could see that we knew where we were going, or we had a general idea. And that can often make the difference in demonstrating that you are competent, even if you don't finish the problem. I've seen many people get jobs who didn't, they thought that they failed the interview because they didn't finish the problem. They didn't have the right return value at the end. But often these problems are made to be so difficult or so time consuming that you're not supposed to finish. And it's really about seeing your process. So that's what all this is about, the process.